Myself, Dr. Kusum Mehta from Jamia Hamdard University, is giving a presentation on sentiment analysis with deep learning, RNN LSTM framework for unstructured tests. According to this, in the recent times, immense information is increasing on the social media data. So, sentiment analysis has proven to be a valuable tool in this field. Machine learning is applicable in many problems like natural language processing, information retrieval, computer vision, and robotics. As per my literature review, according to Zhang and Zhang discussed machine learning for sentiment analysis and used TF-IDF to calculate the weight of words for analysis. The Bhavita et al. Proposed a comparative study of lexicon and hybrid approach and CNN, DNN, RNN for sentiment polarity and feature extraction on social media data. Zhang et al. Used three different CNN models for extracting the feature. Sensitive features were extracted by sentiment and semantic embedding. Kimmett et al. Used CNN and LSTM on seminal datasets. Aspect sentiment analysis was used for the classification. Jengiz et al. Used CNN, RNN, and LSTM for finance tweets for improving the deep learning technique efficiency. In this aspect-based analysis was done. Jong et al. Used a topic modeling technique on social media data for the identification of products in customer reviews. Liu et al. Worked on the movie reviews with CNN and LSTM, showed the impact of textual features like word count, etc. Wu et al. Used LSTM by LSTM by comparing the study with the hybrid approach on datasets on semi-well workshops for the classification of sentiment. Proves that all use LSTM on movie review dataset for improving the accuracy. Pam et al. Used analyze the travel review in five aspect sentiments such as value, cleanliness, service, room, and location were determined. Gupta et al. Combined semantic and sentiment features in the long-term, short-term memory model. Now I am comparing the machine learning and deep learning. In machine learning, first pre-processing is done, then feature extraction, and after it modeling, and then sentiments are classified into positive and negative. And in the deep learning, also pre-processing is done, but in this case, the deep uh, embedding is done, and after that, hidden layer, dense embedding is done, and after that, hidden layer is helpful in classifying the sentiments to positive and negative. Now I am comparing the DNN and CNN. The DNN architecture uses DNN stands for deep neural network. CNN stands for the convolutional neural networks. The DNN architecture uses mathematically sophisticated model data comprising three layers. First one is input layer, second one is the hidden layer, and third one is the output layer. The input layer is used for feeding the data. Second, the hidden layer containing the neurons, and third, the output layer having one or more neurons. Data is also fed after pre-processing. While CNN is a feed-forward neural network, convolution layers and the pooling layers are used as input for the classification layer. Feature resolutions are reduced by the pooling layer. Classification is done by a fully connected layer. It is used in text feature extraction, etc. Deep neural network is used in text feature extraction, while convolutional neural network is used in many areas like natural language processing, computer vision, recommender system, and mainly used for unstructured data having many layers. Now, RNN versus LSTM. RNN it stands for recurrent neural network and LSTM stands for long short-term memory. A neural network whose neuron connections make a direct cycle is recurrent neural network, while in long short-term memory, it is a typical type of RNN and with one cell extra called LSTM. Things are remembered for a small duration of time in RNN if loads of words are fed in the pieces of information are lost, while in LSTM it uses long memory as an input to the hidden layer. Now, research methodology for sentiment analysis. We have used five types of data sets are used. IMDb, music review, sentiment 140, tweet, semi-well, and Kagle data sets. Tweets MML datasets containing geopolitical entities about Disney and on-site tweets are taken. IMDb movie reviews containing the comments of people. A total of 40,000 samples were divided into two classes, positive and negative. Music review dataset containing user comments obtained from the Department of Computer Science at Johns Hopkins University. Sentiment 140 from Stanford University containing tweets of product labeled with polarity 0 negative and 1 as positive. Kaggle datasets were collected by searching the web pages of Amazon.com. The research is focused on the comparison of various methods. The experiment is done with all studies. TF, IDF, and word embedding are used with a model on two stages. In the first stage is the pre-processing stage, data is clean and feature extraction is done, and in the second stage is the training stage. So these are my results and discussion for tweet semi-well, accuracy, precision, recall, and F1 score. These are the results for data split. When we are splitting the data, these are the results that this is how much accuracy for tweet semi-well, for IMDb, but the value of precision, the value of recall, the value of F1 score. Now the performance comparison, when we train the models, what is the performance comparison of different trained models? This is as follows for Navy based, SCM, DNN, CNN, LSTM. These are the values which we obtain from the performance comparison of different trained models when we obtain the accuracy, precision, recall, and F1 score. Now we come to the conclusion part. In this paper, various methods of sentiment analysis are calculated by traditional model like Navy-based and SVM versus deep learning model. The TF, IDF, and word embedding techniques combined for the transformation of input before feeding into the model. Experiments have been done on various data sets of different topics, related topics and reviews. Precision, recall, and F1 scores are calculated as shown above in the table. LSTM is a specific type of RNN with extra cell, although naive-based and SCM also showed results satisfactory. However, vectorization and tokenization were not efficient for the TF-IDF approach. The sentence tokenization and training with deep learning method give the better result. That when we tokenize the sentence and training is done with deep learning methods, it will provide us the better result. Now come to the future scope. The purpose of comparing different techniques related to different studies guide researchers for achieving good results. Future studies will be focused on a hybrid approach. We will take combination of machine learning and deep learning, and then we will make the hybrid approach of it. Thank you.